Good morning all. I've just bought this power supply on eBay. It's a mains input there, live, neutral, to I think dual outputs. I think it's 5 volts and 12 volts. It says 1 amp, but it doesn't say whether that's 1 amp each or 1 amp between them or what it is. So I'm not quite sure. So let's just take a quick look at this on eBay. So this is it. It's an AC-DC full isolated switch power module. Now fully isolated because of course it's got a transformer in there. AC to DC dual output, 220 volts to 12 volts and 5 volts isolated switch mode power module. They call it a buck converter, but it's more of a power supply really. The spec is that input can be AC 85 to 264 volts or DC 110 to 370 volts, and the output is DC 5 volts and 12 volts with an output current of 1 amp. But as I say, it doesn't really say whether it's 1 amp per output or quite what it is. Let's just scroll down to some more data. So below we've got a couple of photos here, and then all this input characteristics stuff. Frequency range on the input 47 to 63 hertz. All that stuff. Output characteristics. Now this is where it just says output voltage 5 volts, 12 volts, rated current 1 amp DC, but it doesn't really say how that's shared. We've got ripple and noise, line regulation, load regulation, and lots of stuff there. But I just find it fascinating looking at all the stuff on this board, particularly the AC end. So here there's a fuse that says T1 amps, that's a time delay fuse. There's a thing there that says VDR, so is that a voltage dependent resistor? And is that the same thing as a MOV? It says 471K, or is that just a capacitor? It actually says VR1 on the board. Then behind that there's something that says NTC, so that'd be one of these negative temperature coefficient thermistors. So these presumably are both to deal with inrush current. That says RT1. So coming around from there we have an X class capacitor. I think down in there you can just about see it says X2. It's not very easy to see actually. Just about see X2. So that's a class X capacitor. That'll be across the mains. Then there's a dual choke, so both live and neutral go in series through a choke. Then down in there you can just about make out a bridge rectifier. You can see the two squiggles which are for the AC input, and then on the other side it'll have plus and minus. Then there's this huge capacitor, so that's 400 volts. Can't see what value that is. I think it was 22 microfarads. I mean, it's not a huge value in terms of capacitance. So at this point on the terminals of the capacitor we've got effectively rectified and smoothed mains. So we've actually got DC, a high voltage DC here. Then we get into all the electronics. There looks like there's a MOSFET there. There's a little control chip down there. It's really tiny. Here's some feedback from the DC end through an opto-isolator. That's a standard PC817 type. And then we can see the two outputs. Now there's a big diode there with an inductor and a couple of capacitors. And on this side a smaller diode with an inductor and a couple of capacitors. So I'm just wondering whether this is the 5 volt end with the bigger diode for more current. And this is the 12 volt end, but I guess we'll find out in due course. So yeah, some more capacitors over here and here. So lots of really interesting stuff on here. And I suppose the next thing I've got to do is power this up and check these two outputs. There's a little LED there, so it should be fairly obvious that this thing has powered up and is providing a DC output, but we will look at those. But I'm not going to put mains into this. No, I'm actually going to put a DC voltage in here. It was actually this here, this input DC 110 to 370 volts, that made me buy this thing, not for AC at all. What I want to do is put a high voltage DC into here and get low voltage DC out, and I'll explain why in a moment. I suppose I should do the eBay thing, shouldn't I? So this one was $6.50 free shipping from Kualilaoliang. That's a bit tricky, isn't it? Now, because there's a bridge rectifier down in there after the choke, I don't suppose it matters which way round I put my DC, because it's going to get rectified by by two of the bridge rectifier's diodes. So it's, well, steered more, not so much rectified, but steered into the correct polarity on the capacitor. So I can put my DC either way around there. None of these other components are going to make any difference. The capacitors won't affect DC. The DC will flow through the two choke coils, and we'll end up with the same thing on here, a DC high voltage, exactly the same as what would happen if you put AC into here. So I guess that's why it can take DC as an input. However, it does need a minimum of 110 volts DC. Now, where am I going to get 110 volts DC? Well, this thing, which is the Minghe BST 900, 900 means 900 watts in theory, this can actually put out up to 120 volts on the output. If you look at these capacitors, they're actually rated for 160 volts. So the maximum voltage this can put out is 120. I need 110. Let's kind of go for a middle value of 115. So I'm going to put 12 volts into here, boost it right up to 115 volts, and then put a short piece of wire from there into my power supply and see if I can get that then rectified back, regulated, I suppose, back down to 5 volts and 12 volts. Let's see if it works. So let's connect 12 volts to the input. I've got the polarity right, haven't I? Plus, minus. Okay, that powers up. Fan's running. So now I want to raise the voltage. That's voltage. Where's current? Yes, that's current. 1 amp, 40 volts. I might leave it at 1 amp just to make sure I don't kill anything. I'm going to take this all the way up to 115 volts. And then I've got to find a piece of wire to connect this to the power supply. So 115 volts, 1 amp. Of course, 1 amp's a crazy current at 115 volts. I could probably take that much lower, but that should be okay for the moment. Let's just switch this on actually and see. Watch it go up. So there, in theory, we've got 115 volts DC on the output. Switch it back off. Right, piece of wire to my DC power supply. Right, so I've attached this bit of twin flex, fairly low current, what we might have called bell wire in the old days. You'd use it for sort of ringing up doorbells and that sort of thing. I've attached that to the power supply side, so I'm just going to strip this back and connect it into the boost converter, and then see if the little light comes on here when we switch on the power. So there it is wired up. Now, as I say, I'm not bothered about polarity, so there's no obvious positive and negative markings here. I've just connected it whichever way around it fell. So now let's switch on the output to 115 volts and see if this powers up. Well, there's no LED on here, so why isn't that working? Perhaps it is. Right, let's check some voltages. So let's switch that on. It says 120 volts. Let's just check that. Yep, 119.8 volts coming out of the boost converter. Now, what have we got coming out of the little power supply? Anything or nothing? Ah, yes, we do have 5 volts there. What do we have here? And we do have 12.3. That's interesting. So why doesn't that little LED come on? Oh, well, that does seem to be working then. We've got 5 volts and 12 volts coming out of that converter. Oh, okay, so maybe it does work. So I'm not quite sure why that LED doesn't light up. I mean, you can see quite clearly that it's wired across this output. This track runs to the LED, that goes through a resistor to the other side. So is that LED been put on the wrong way round or something. That would be annoying. Right, I found another way of doing it. Since LEDs obviously don't work, I found a teeny tiny little 12 volt incandescent lamp. So let's try it with that little bulb on the circuit. Switch on. And on comes the little 12 volt lamp. Fantastic. Switch off. And it stays on for a while because of capacitors. And so that works. But the question is, why am I doing this? Well, the plan is to take 12 volts from this big car battery, which is being charged from a solar panel via one of my PWM5 solar charge controllers. That's modulating nicely, so that's fully charged. It's actually being charged from this 80 watt panel, the right hand one. So that gives me 12 volts, but of course it's halfway down the garden. So the idea is to have the boost converter out here, boosting this 12 volts up to a high voltage. Now I'm not sure I really want to go as high as 120 volts just yet, but then running that power down the garden all the way back, and it's quite a long way. The wire that I just used is this reel here. It's I don't know, 100 meters or so of that twin flex. Run it down a length of that and then run it into the workshop and transform it back down to a useful low voltage again. So the idea is that a long length of this quite thin wire, if you put a high voltage on it, won't present so much of a loss as if you're putting a low voltage and a high current through the same long length of thin wire. So this boost converter would be outside, boost the voltage up, run it down this long length of thin wire, and then buck it, I suppose you could call it, or transform it back down to low voltage DC once I get into the workshop. Now, the savings you get by having a high voltage on a thin piece of wire are probably going to be offset to some extent by the various conversion processes. This boost conversion, it's a 10-to-1 voltage boost, and then the transformation from high voltage back down to a low voltage. Is that going to offset the benefit of using smaller amounts of wire? I mean, certainly in terms of the amount of copper used, you could perhaps, although there's quite a lot of copper on these circuit boards, so maybe even that doesn't add up. So maybe this is all a bit pointless. But I'd quite like to build it as an alternative to this system. Now this system has these very thick copper wires. This is I think 20 amp or 15 amp twin and earth coming onto this panel with these charge controllers, two of which now I don't think work. I think only this one is working, and then connected to my batteries, which are just outside the workshop window. Batteries paralleled up, and then 12 volts from this system is tapped off here through a fuse and then runs through this wire through the window and into the workshop. And although this system still works, it is all getting a bit ropey now, and it'd be quite nice to have an alternative system using DC to DC converter technology, because I just love that technology, as an alternative to the existing low voltage 12 volt system. Now one problem is that this is the only boost converter I've got which can generate this high voltage, 120 volts. The other boost converters I've got several of, which only go up to 80 volts, may not be enough for this. So one thing I wanted to try was how many volts, or how low can I go in terms of DC voltage and have this unit still switch on. So let's take it down to 110, which was the minimum it says it can operate on. So 110, 1 amp again. That's not a very sensible current limit, but let's give it a try. 110 volts. Now I think that came on at somewhere below 110 volts. So let's keep trying it and taking the voltage down. Okay, let's try it at 100 volts. Yeah, that works. The 12 volt output has come on. Okay, let's try 90 volts. Yeah, that's come on. Well, I'm just going to keep going down. Okay, 80 volts. Now this is the maximum voltage that my other boost converters can produce. And it even works at 80 volts. This is well below the input voltage spec now for a DC voltage, but it's still working. Of course, it may not work as reliably with only 80 volts. Oh, well, in that case, let me try using the other boost converter. So this is the boost converter that I really want to use, because I've got a couple of these things, one of which I can sort of just leave outside permanently in a box, in a weatherproof box, of course. So let's plug 12 volts into that, and I've no idea what voltage this is set to. Well, it's only set to 40 volts. That even comes on at 40 volts. It took a while to come on, but that's pretty amazing, isn't it? So this thing works at a voltage well below its official spec. I'm not sure how reliably this is working. Of course, it may not be working very efficiently like that, but let's wind this up to the full 80 volts. Right, let's plug that in. I found my Bourne's trim pot, so V adjust. Yeah, that's going up. 60, 70. This actually does go a lot higher, I found, but the caps, I can't remember what their rating is, so perhaps I'll leave it at 80 volts. But yeah, at 80 volts, certainly this thing works. The 12 volts is on. I suppose I could just check the 5 volts as well. And yeah, that 5 volt output is reading 4.99, despite the fact that that LED doesn't work. So is this a viable system? This boost converter sat in a weatherproof box halfway down the garden next to that 12 volt battery, boosting the voltage up to 80 volts, or maybe even a bit beyond. Let's just check those capacitors. Yeah, they're 470 at 100 volts, so maybe you can get more out of this. Yeah, turning the voltage into 80 volts, that running down a very long length of fairly thin wire, and then a power supply at the other end, bringing that back down, DC on the input, not AC, bringing that back down to a useful 12 volts and 5 volts for use in my projects. Is there any point doing this? I quite like the idea myself. Let me know what you think in the comments. Cheerio. Well, that's a bit weird. That LED started working now. It's a red LED and it's now on. Why wasn't that working before? Is it a bit loose? Weird. So there's an LED on the 5 volts and a bulb on the 12 volts now. Weird.